How many of you have a favorite song? Or better yet, how about you like to listen to music solely for enjoyment? Now I want you to imagine a society where music education has been made mandatory, where students must take courses in scales, modes, meter, and harmony before they ever get a chance to play or even hear any real music. This is how mathematician, author, and longtime teacher Paul Lockhart begins his groundbreaking essay, A Mathematician's Lament. He describes a musician who wakes up from a terrible nightmare. Relieved that it's only a dream, the musician says, of course, no society would ever reduce such a beautiful and meaningful art form to something so mindless and trivial. No culture would be so cruel to its children as to deprive them of such a natural, satisfying means of human expression. Come on, how absurd. You know what? This is exactly the kind of nightmare that exists in the present system of mathematics education. The math curriculum doesn't just need reform, it needs to be scrapped. I'm going to quote Sunil Singh, who I introduced to you in my last speech, and make a claim that education has domesticated and caged mathematics to the point where its original purpose, unbridled awe and wonder, has been shaded into obscurity. So this speech is supposed to address a specific policy. Well, I'm not going to go into too much detail on this policy because this is something that you are all going to be familiar with already. This is nothing more than the linear progression of math education that we all go through, and we're told that this math that we learn is supposed to be important and useful to our lives. This policy says we all start with arithmetic, and then we march on through algebra, geometry, trigonometry, and maybe some of us get to calculus, but during this process, so many of us will come to identify as just not being math people. This is a failure of education. A name that you may have heard of is one of the leaders in the fight to help people stop believing that there are math people and non-math people. This is Stanford Professor of Mathematics Education, Joe Bowler. She says many kids go down a faulty pathway that is very damaging to them early in their career. They see math as a long ladder, if you will, of rules upon rules upon rules. They're not connected, and they don't mean anything. Now, I bet that many of you can relate to this next quote by Lockhart. He says, I don't see how it is doing society any good by having its members walk around with vague memories of algebraic formulas and geometric diagrams and clear memories of hating them. So what is a solution to this problem? Well, someone who has offered his perspective is another ambassador to the Global Math Project, Dan Finkel. Dan has a PhD in mathematics and is the founder and director of operations for a company called Math for Love. He's also the creator of the award-winning mathematical board game, Primetime. Dan gave a TEDx talk in 2016 that I absolutely suggest that you all check out, called 5 Principles of Extraordinary Math Teaching, and this video has already surpassed over 292,000 views on YouTube. These principles are: 1, start from questions. 2, which I cannot stress enough, students need time to struggle. And I'll add to this, make mistakes. Number 3, you are not the answer key. Here he's talking directly to teachers, saying you are not the answer key. Number 4, say yes to your students' ideas. And 5, one word, play. So before I finish, I would like to challenge all of you to engage in a piece of mathematics sometime in the next week. Not because it's assigned or because you have to, but just because you're curious to learn more. This can be any topic you're interested in any branch of mathematics. But if you can't think of anything, I'll give you an option. This is one of my favorite problems, and I guarantee you'll be able to understand it. So just pick any natural number, any counting number. 1, 2, 3, 15, 42, million, 26. It's either going to be even or odd. If it's even, I want you to divide it by 2. If it's odd, you can't divide it by 2 and get a whole number. You're going to multiply it by 3 and then add 1. So pick a number, call it n. Either you're going to have n over 2 or 3n plus 1. And those are the only rules. It's going to create some sequence of numbers. Let's say we start with 6. Well, we're going to divide by 2 and get 3, and then 10, 5, 16, 8, 4, 2, 1. If you keep going, go back to 4, and then 2, 1. So we end at 1. Would any number we pick always end at 1? Or maybe go off to infinity? Is there some pattern here? We're going to look at this problem more in my next speech, but then we're going to really fall down the rabbit hole of mathematics and hopefully have a lot of fun. I'll see you then. Thank you.